Welcome to the Deep Dive, where we take an in-depth look at complex topics. Today, we're diving into Neuralink's CONVOY study, the potential of brain-computer interfaces for controlling robotic limbs. Imagine, right, like a future where amputees regain physical freedom, not just through, like traditional prosthetics, but through technology that connects their minds to robotic limbs. Pretty wild, huh? So this is the kind of future Neuralink is working towards. And you might be thinking, brain implants, really? Is that even possible? But get this, Neuralink has already made some pretty remarkable progress. They've successfully implanted their brain chip in 2 human patients as part of their PRIME study. This study is focused on helping people with paralysis, control digital devices just with their thoughts. One of these patients, a 29-year-old named Nolan Arbaugh, who was paralyzed, can now play chess and video games hands-free, all thanks to, this implant. And this is just the beginning. The CONVOY study takes this technology, like a step further. They're exploring how this implant, the N1 implant, can be used to control an actual robotic arm. This has the potential to revolutionize the lives of amputees, giving them a level of control and dexterity that traditional prosthetics, they just can't match. Here's where things get even more interesting. Neuralink isn't the only company making waves in this space. Tesla, the electric car manufacturer, they're also developing a humanoid robot called Optimus. Now, you might be wondering what a car company has to do with, brain implants and robotics. Well, Elon Musk, he's the CEO of both Tesla and Neuralink, and he has a pretty grand vision. He believes that by combining Neuralink's N1 implant with Tesla's Optimus robot, we could create a future where people with limb loss could have cybernetic, imagine that, like controlling a robotic arm or leg with the same ease and precision as, your natural limbs. That's the kind of future Musk is envisioning. Tesla's been putting a lot of effort into developing Optimus. They've been really meticulously refining its design, focusing on things like, finger and hip and leg movement to make sure it moves naturally. They even studied human anatomy, right, to make sure Optimus's movements look and feel as realistic as possible. Recently, Tesla released a video showcasing Optimus's new hands. These hands have 22 degrees of freedom, which is getting pretty close to the 27 degrees of freedom of human hands. So this means Optimus is becoming more and more dexterous, capable of performing increasingly complex tasks. And remember that video of Optimus catching a tennis ball with its new hand? It went viral. So it's clear that both Neuralink and Tesla are making significant progress in their respective fields. But what happens when these two technologies converge? What happens when we combine the power of brain-computer interfaces with advanced robotics? That's the question, at the heart of this deep dive. We're exploring the potential of these advancements, but also the ethical and societal implications they raise. So let's dive in. Okay, so think about the possibilities here for a second, right? The CONVOY study, it's looking into how someone, could control a robotic arm using literally just their thoughts. And then pair that, right, with Tesla's Optimus robot. I mean, Optimus is being designed, to perform a wide range of tasks, like everything from simple household chores to, complex industrial operations. So, it's not hard to see how these two technologies could work together, right? Imagine a future where someone with, a limb difference could control a robotic arm or leg even seamlessly. They could perform actions with such precision and control, and maybe even surpass their previous abilities. We're talking about restoring lost function and giving individuals the power to live more fulfilling lives. But this vision, it goes beyond simply replacing what was lost. Elon Musk talks about these cybernetic superpowers. He really believes that that Neuralink enabled individuals could potentially exceed the limitations of human biology, enhance strength, dexterity, even new sensory experiences. These are just some of the possibilities that this technology could unlock. It's a pretty exciting prospect, right? But it also raises some pretty important questions. As we move towards this future where technology is becoming more and more intertwined with our bodies and minds, we got to think about the implications. How do we ensure that everyone has equal access to these technologies, and what safeguards do we need to put in place to prevent misuse? These are just some of the questions that we need to really grapple with as we navigate this uncharted territory. I mean, this collaboration between Neuralink and Tesla Optimus really highlights how quickly technology is advancing, and it has the potential to completely change what it means to be human. Restoring physical freedom to those who have lost limbs. This technology, it could go so far beyond prosthetic. Think about it. being able to control machines with our minds raises, some fundamental questions about the future of like how humans and machines will interact. Could we get to a point where the line between, human and machine becomes like blurred? Could they work together seamlessly? Each one enhancing the other's capabilities. The possibilities, they seem, endless with brain-computer interfaces, right? Like controlling our smart homes, our vehicles, just with our thoughts, enhancing, communication, unlocking new levels of creativity. It's mind-boggling. But as with any, revolutionary technology, we have to address the potential risks and the ethical considerations. For example, data privacy and security are super important. Brain data is incredibly personal, right? So we need really strong safeguards to prevent misuse or unauthorized access. And then there's the question of like, cognitive enhancement. If these technologies become widely available, will they make, existing social inequalities worse or create new ones? We're on the verge of a new era of human machine integration.